Web-Performance Meetup in Hamburg.
Nochmal von vorne.
Nicht gestellt. Hallo, herzlich willkommen zum 20. Web-Performance Meetup. Besonderer Dank heute an Kai von Cassini Consulting für das Hosten und Getränke und Essen. Dank an Vitaly, unseren Redner heute. Oh. Wer kennt Vitaly Friedman? Wer kennt ihn einmal? Oh, ist noch Nachholbedarf.
Kein Problem.
Vitaly hat das Smashing Magazine gegründet. Das ist eine Internetzeitschrift mit dem Fokus auf UX und Frontend. Weltweit bekannt, riesengroße Geschichte. Unbedingt mal lesen.
Er sagte nur so. Stimmt nicht.
Genau. Und Vitaly hat eine Geschichte mitgebracht heute. Genau, Improving Smashing Max Performance. Und darüber wird es die nächste Stunde so gehen. Ja, ungefähr. Ja, viel Spaß und
Dankeschön. Okay. So, first of all, who doesn't speak German? Who doesn't understand German?
I don't understand.
Okay, so we're going to do it in English. It's easier for me as well, so I hope you don't mind. But you can ask questions in Russian, Polish, French. Please don't ask me in French, German or English or any other accent or whatever, it doesn't matter. So first of all, it's very nice to be here today. It's actually my first web performance kind of focused meetup. I think it's great that something like that like this exists. I also lost my voice 4 days ago and successfully recovered it 2 days later, and then successfully lost it 1 day afterwards, and then ran a workshop, which was interesting. And now kind of I'm somewhere in between. So I'm trying to do my best to be as loud as I can, but I won't be too loud, I'm sure of it. But this is going to be quite loud, so that's kind of a nice replacement. I also had some secrets and stuff if you like, you can get them later. Probably too many, but still useful. Alright, so today we're going to talk about performance, who would have guessed. Now performance is a big deal. I care a lot about performance. I care about it so much that I actually tend to wrap my clients, people I work with, around it to make sure that they actually respect performance as well. Now it's very difficult to convince people about performance and why it's important. But for me it's really, really critical. So I'm trying to kind of include as much good work, as much performance optimization work in our site and in the other projects I'm working on as possible. But more specifically, I do a lot of consulting with companies, small companies, big companies, large companies, mid-sized companies and so on, where it's really specifically focused on front-end and front-end performance optimization. So most of the stuff that I'm going to show today actually derived from real-life projects that I was working on, or that I actually saw working or not working, because this is what I care about most these days. I don't care about what is supposed to be working or things that are supposed to, fail or not. I really care about results, like actual hard data, when things actually work or don't work. So this is me, at least this is how I used to look like back in the day, when I had hair. I'm Smashing Magazine around all the time, and I'm still editor-in-chief of Smashing Magazine. So basically every single article goes through me, more or less. But also at the same time I do a lot of front-end stuff as well. And my background is I started doing websites, building websites in 1998. How many of you remember Adobe Image Styler? Really? 14, nearly. Wow. This is how old I am. So Adobe Image Styler was the only version of, 1.0 was the only version of Adobe Image Styler ever. It coexisted with Photoshop 3.0 back in the day, and it was released I think 1997, and there was no other version of it. Now I bought a CD with Photoshop and Illustrator and Fireworks and everything for $1 back in the day. It had Image Styler as well, so I started playing around with Image Styler, though everybody convinced me, kind of tried to convince me to use Photoshop instead. But I was, stubborn as always, so I used Image Styler instead. And Image Styler was cool. I used it back actually until 2006. Now the main reason why I had to switch from Image Styler to something else, like Photoshop, was because the maximum canvas size for Image Styler was 800 times 600, which was kind of a problem when it comes to responsive websites. But yeah, this is kind of my background. I did it all, like table-based layouts, CSS layouts, everything. It was a lot of fun. Sometimes not so much fun. So I know how many of you have to design responsive email newsletters actually? Responsive email newsletters, anyone? Who is enjoying it? No. out. No, this is very strange. No, normal people don't do that. But you know, it's kind of my world. But then at some point I actually jumped into front end in 2000 when I was freelancing, and then now, like 4, 5, 6 years ago, into performance. So, like this is the magazine, and we are going to talk about it today, which is actually quite an exception. Normally I don't talk about it, but I want to share a few things we've learned over the last few months as we're optimizing the site to ensure that we have a really good and really fast website. Now, performance. Performance is a big deal, but most people actually think that performance considerations are often an edge case. Or when we talk about performance optimization, we're talking about these people, weird people with slow connections who want to access our sites. Now, there is no real difference for the user between a site being down and a site being inaccessible because the connection is too slow or there are too many blocking resources. Now, I think it's quite disrespectful and almost shameful that we often have this wonderful experience when web fonts are loading, when you see that the content is probably already there, the HTML is there and CSS is there, and the HTML DOM tree has been constructed and CSS OM tree has been constructed and the render tree has been constructed, but we still don't see any content because web fonts are blocking. You know this experience? Wonderful, perfectly wonderful blank screen with underlines, text underlines, link underlines, because we don't have the web fonts still yet. Now this is disrespectful. This is not okay. Now these edge cases, usually when you think about edge cases, think about stuff like this, right? This is an edge case. This is a nice way of dealing with an edge case. Okay, it's fake. It's fake. But for like 10 or 12 minutes, as I was not displaying the score during the game, I was almost sure, almost 100% convinced that somebody must be, applying overflow hidden on this container and then scrolling manually. I was almost convinced. I can't, I don't know if it was the case or not, but I'm pretty sure it was. Now, they were not prepared for this edge case. Now, we have a bit different edge cases that are not as radical as this one. This is my favorite edge case. So, I'm using T-Mobile. And T-Mobile kind of differentiates countries into 3 groups. Friendly countries, not so friendly countries, and really not friendly countries. Okay? So I was in Russia, in Moscow 1 year ago. Can you guess where Russia is? Among these 3 groups of countries.
There?
Yeah, some things that Russia is in group number 1, 2, 3, 4. Yeah, so Russia is of course in group number 3. Now if you're using roaming in Russia, you are going to pay 79 euro cents per 50 kilobyte of data. I would say that it's quite expensive. But we need to visualize it, and this is what I always do when it comes to clients who don't understand why performance is important. If you want to visualize it, well, if you want to use roaming and you go on vogue.co.uk in Moscow using roaming charges, you're going to pay 93 euros and 13 cents just to see this one page of vogue.co.uk. Now, why is that? Well, of course, they have a really long page, but not only that, they are delivering retina images to everyone by default. And so you end up with something like this for 6-7 megabyte for just the front page. Now, at this point, I actually lied because, well, as you can see here, the connection is going to be disrupted or interrupted, stopped after 5950. And because they have everything blocking, web fonts blocking as well, you will see a perfectly empty page for 5950. Now you can get the same with about blank for free, right? You don't need that. Now this is not cool, and the reason why it's not cool, because for the same amount of money, you can actually get 16 print editions of Vogue in Moscow as well. Now this is just not cool. But in our case, our common edge case is of course web fonts, and this is the experience that we kind of have to deal with, or actually our users have to deal with. You come to the page, you see probably nothing, or maybe just a few fonts, and then the first font appears, then the second, and the page kind of is constructed. Now, I really hated this fact because when I was traveling, I traveled a lot because I'm homeless. Not because I have to be homeless, just because I chose to be homeless. It's actually the best thing that happened to me in years. I'm not kidding. Seriously. You should try that. Unless you, well, me and my girlfriend were traveling around. But But the problem is I always have to work when I'm traveling, and I always have to deal with average connections. So it was really important for me to actually be able to read our articles on an edge connection. It was really important for me to be able to edit our articles on an edge connections as well. So something like that was just unacceptable. Now, you might have heard of the work that the Guardian guys did back in last year, actually. Have you followed what they've been doing over the last year too? So the performance work they did was quite remarkable. It actually heavily influenced what we did on Smash Magazine as well. So I would love to actually dive deep into this use case first, in this case study first, kind of give you some settings or some context about what we then applied to our work. So the Guardian use case is simple. Back in last year actually, they had a main problem, and the problem was that they had a really dropping print circulation with mobile. So they wanted to kind of grab these people that actually they were living the newspaper on print. They wanted to kind of pick them up via mobile. They actually also had a rigid mobile and desktop site. It was difficult to maintain. It took too much time to develop. It was just slow, and they wanted to replace it. They wanted to focus specifically on mobile experience first, and then long-term create this new responsive client-side architecture in order to be able to replace the existing sites. So the ultimate goal was easy and simple: one code base with one responsive site. And this is how they did it. They actually, the solution to actually make it all work for the project was to follow a mobile-first deal-free design with a strong focus on progressive enhancement. Now, you know, everybody knows what progressive enhancement means, right? You basically start with a code base with something very foundational, basic, that just works, it's accessible, it's clean markup, a simple foundation that actually always works. And then you progressively enhance for capable browsers. Now, they actually started with mobile-first deal-free design, and what it means is, well, they had an existing mobile site at the time, and it was slow, but they actually forked it, they polished it up, they created a new version of it, they improved performance, they improved navigation, they improved reading experience, they improved usability, they improved, pretty much everything, made a very shiny, beautiful, nice mobile view, and then they started looking very carefully. So what happens if we go from mobile to tablet? How much time do we need to make it work? Can it actually work with our CMS or with our existing architecture? Can it work with our resources, with our people, and so on and so forth? They just looked at it very closely and then started building. And as they were building, they're actually looking, okay, so what else can we do? So once we reach tablet, can we go to desktop? Can we go to TV? And then maybe we could go somewhere else. Could use a sandwich, by the way. So maybe we could, can we in the end really start small with this mobile view and then end up with this big view? So this is what this mobile-first approach meant, but still redesign was also very important, because at the time when they were doing the redesign, nobody really cared so much about the mobile presence. It had maybe 4-5% of the overall traffic. So many design decisions could be made really quickly without having to go to the, to the boss or to the manager to get a sign-off. So this is kind of the solution they went with, and it worked really well. Now this is the architecture they used, and it's again very simple. You have editors working with editorial tools, and you have authors working with CMS tools, and they write and push content using Write API, and they have a database, and then they have a Read API, which actually reads out this content and pushes it to the iPad app, iPhone app, Android app, Windows Phone app, and responsive website. Now at this point, it's important to mention that actually they wanted to have one code base and one responsive site, but at the same time having all these different ecosystems kind of filled with Guardian content was also important. So their strategy was not just one responsive site, but actually also all the different apps combined, just to reach as many people as possible. Now what was really crucial for them, and I really didn't believe that, I didn't understand the importance of it until we actually tried it out ourselves. They really tried hard to identify what core content means, or what core HTML means, or what core CSS means. Now, normally it sounds like quite boring. Why would you want to identify that for your progressive enhancement and stuff like that? You just build stuff and then you progressively enhance. But I can't stress enough how important that is. And you'll see later why. Because what you define here will actually define also the way you actually reflect the way you load assets when the site is being constructed in the browser. So they came up with this priority list. to define this core experience, core HTML, core CSS, and core content. Now, they wanted to define core very specifically. So core content for them doesn't rely on JavaScript. Only one main feature image considered to be core on the front page. I'll ask you why in a second. No Ajax support because they don't rely on JavaScript, so it means that all the interactive ratings, comments, and live scores are not core content. They use this technique, cutting the mustard. Are you aware of this technique? Okay. Cutting the mustard to kind of buckle browsers into two groups, the stupid ones and the smart ones, like the modern ones and the legacy ones. Web fonts are not considered to be core content, so they're not loaded by default. Oops, sorry. Now what it means for us is, well, first of all, web fonts are loaded asynchronously, so they're not loaded by default, which means the users see a full web font first and then they're loaded asynchronously. But what it also means, only one main feature image is considered core, which means you can't delay loading of images, right? Like you can, of course, with JavaScript, but not by default. There is no something like async or defer for images. So that means that images are loaded with JavaScript, but only one image is loaded by default, so it's just going to be probably image source. And all the others are going to be loaded with JavaScript. Please keep it in mind. I'm really curious to see what do you think why they did that. And at the same time, if you don't have JavaScript, you still should be able to access all the content and read the news, right? This is kind of the point, which is quite interesting itself. But this is just the core experience, the worst experience you can get, the basic experience you can get. But even in this experience, you are able to read the news without waiting too fast for the page to start loading. And once they had this core content defined, they were able to actually define, group all the content in three groups, in three types. So we have this core content, which is essential HTML, CSS, and usable non-JavaScript enhanced experience, right? They have enhancement, which is, as you progressively enhance, you just add more stuff. Then they have extra JavaScript, geolocation, touch, enhanced CSS, web fonts, widgets, and images, right? And then leftovers, which is stuff that most people don't need to actually start reading the news. Analytics, advertising, third-party content. Well, users don't need to see that, don't need that to be loaded in order to read the news, right? Again, we have a really, very clear user-centric perspective here, not talking about business objectives. Now, I know that this is very hard to achieve. Like putting advertising in this group, like this is very hard. You're going to have lots of interesting conversations with marketing people, right? Well, we did the same thing. And we actually kind of moved the priority away from advertising. But in the end, we didn't see, when we implemented it, we didn't see any difference in terms of click rates, in terms of ad impressions and so on. So there was no difference. So in terms of click impressions or ad impressions, it doesn't make any difference if it's in this group or in this group. But you will see why in a second. Now, once you have these three groups, the easiest thing you can do is to load them in that order. So you push core content as fast as possible into the browser, so it can start render the page right away, right? But at the same time, nothing from enhancement is blocking anything from core content. But once you have enhancement, well, you're loading enhancement only on DOM content ready when the page starts rendering, right? Or DOM content loaded. And then you load leftovers once this has completely finished, right? So you load leftovers on load when everything is finished. Okay, so what does it mean? Well, nothing from enhancement blocks anything from core content. Nothing from leftovers blocks anything from enhancement. Nothing from leftovers blocks anything from core content, of course, either. Right? Does that make sense? Now, this is very simple. This is like the simplest you can get. As a result, you have a really clear separation of concerns. We have your HTML request, CSS request, CSS, images, loaded with JavaScript, fonts, and so on and so forth. And then you have a load event, and this is where you're loading analytics, advertising, third-party content, and so on. Now, why do you think they load images with JavaScript? I mean, it's clear that we're deferring JavaScript here because we don't want the content to be blocked. Right? But images do not block content. It's not like they're blocking, until they're loaded, nothing is displayed. Why would they load images with JavaScript?
You can design bandwidth, image canvas size, screen resolution,
yes,
stuff like that.
Okay, well this is one point. You can actually really, at runtime, you can decide which image to load, for example. But there's a really more pragmatic, much simpler reason for that. Any ideas?
The order?
The order could be, but it wasn't. Now, you know we have 6 parallel requests per connection, per domain, in browsers. They didn't want to actually leave it a chance to the browser to decide to block the rendering of HTML and CSS while images are being downloaded. Because they wanted to push HTML and CSS as fast as possible. So this is kind of the priority one. Nothing can be blocking, even images. Because, well, not because they want to be fancy, but just because in this group, in this kind of architecture, and images are in enhancement and not in core content. And nothing from core content can be blocked, in principle even, by enhancement, right? And this is why they're loading images with JavaScript. Now, to me, it sounds a bit too rigid, too, I don't know, complicates things a bit. Because now you're loading all images with JavaScript, and it gives you some, some stuff you can do in terms of how you load images, how you choose images, you can lazy load images and so on. But maybe it's a bit too much to the complexity. Especially because, we have 1, 2 requests, and I mean, even if we have 4 images left, that's fine. It shouldn't be a problem. But, this is what they went for. Now, yesterday I was lucky enough to see a wonderful performance dashboard with a new tool called Open Speed Monitor, which is going to be released very soon. And it's a really cool thing because it allows you to kind of have a nice dashboard and actually check how a site performs using web page test. There are other things like that, like just monitors to kind of monitor performance. The simplest one is, well, you put the pages per minute against time in milliseconds for the loading time in milliseconds. And then every single time you see a bump, let's say here we have a little bump, you can actually go and right away in real time kind of check what was happening, what was going on. So here you see that that we had a drop in traffic, and here at some reason, I don't know, what is it? Its load event took a bit much more time to to complete for some reason. So you can actually have this association between these two events, which you probably wouldn't have otherwise. But again, if you're having a fancy website or a relatively large website, you probably have this anyway, something like that. If not, it's really helpful to kind of be able to communicate design decisions and communicate the problems that we have with traffic and actually lead them backwards to performance issues. So this is really helpful. But of course, if you want to deliver content fast, you have to remove everything that's blocking. And obviously JavaScript is blocking. Now, why do we put scripts at the bottom of the page, actually? JavaScripts? Yes?
Because it completely blocks the execution of the whole page and also blocks downloading of other resources and
Yes. So, exactly. So the problem is, when we start loading a page, well, the HTML is, well, the browser receives HTML, constructs a DOM, browser receives CSS, constructs the CSS OM, and they're both kind of applied to the DOM. Well, CSS is applied, CSS OM is applied to the DOM, and then you have a render tree, and then this render tree can be used to display the page. But if you have JavaScript somewhere in the middle of the page or in the header of the page, well, the browser is going to wait with the construction of the render tree because this JavaScript may manipulate the DOM, right? So this is why it's waiting. And while it's waiting, nothing happens. And we don't want users to wait, right? So this is why we need to load JavaScript asynchronously. I actually defer loading of JavaScript in general. So that while JavaScript is being downloaded, browser still can parse the document and show content, for example. So the Guardian, they use this wonderful function called isModern to define, to kind of differentiate between stupid browsers and smart browsers. But more specifically, they load this enhanced JavaScript only for capable browsers. So they don't want to push too much JavaScript to stupid browsers. But they're using both async and defer. Why? Or what is the difference between async and defer? Well, defer is an old attribute we used to have for a long, long time. And async is a new shiny HTML 5.1. But what's the difference?
One keeps the order and the other does not.
Yeah, so async keeps the order, defer keeps the order. So if you have a jQuery and then you have jQuery plugin, you want jQuery to load first and then jQuery plugin to load next, right? So you're using defer in order to ensure that they're both loaded asynchronously, but specifically in that order. But with async, you're telling the browser, dear browser, do whatever you want to do. I don't care anymore. I give up. Well, I don't give up, but I don't care. So do whatever you think is best. But why would you use both?
Because all browsers don't know async.
Yes, so this is basically just you're using async and defer, and stupid browsers, if they don't understand async, well, they're using defer, it's kind of a fallback, but smart browsers are going to use async instead, because it's prioritized. So that's nice. So you can use both, right? Okay, and again, this wonderful feature, this wonderful function is quite fancy, but what does it look like? Now, how would you do this? How would you differentiate between a stupid browser and a smart browser? Or a legacy browser and modern browser?
User agent.
User agent string. Okay, let's talk about user agent strings. I like user agent strings. I like it so much, I go every single day to a page to check my user agent string. Just because it's fun. I always end up with something different and new. So if I look at my user agent, and I'm running Chrome now, I will find out I'm Mozilla 5.0. At the same time, I'm Apple WebKit, and I'm actually KHTML, like Gecko, but also Chrome, and at the same time Safari. Now this is how reliable user agent strings are, and yes, you can do some analysis and make it work in the end, but this is just dirty, and not so much fun. Now, you know the story why we have this kind of mess with user agent strings? Well, it goes back to Netscape and everything, but this is just one part of the story. But the second part of the story is what happened. It actually, I don't know if I should say it loudly, but yeah, well, the main fault is iPhone. Because when the iPhone came out and it supported all the wonderful mobile features and had a wonderful browser which we could use, it also had specific user agent string, and everybody started optimizing for iPhone. So people started actually looking into user agent string and optimize for iPhone. But then other vendors came and said, everybody's optimizing for iPhone, but not for us. This is not cool. Let's pretend that we're iPhones too. Right? So user agent strings, mobile user agent strings are quite creative. And again, in this case, I'm pretty much everything, Mozilla, Chrome, and Safari. And mobile user agent strings are not much better. So I don't like user agent strings, especially because you also need regular expressions and you also need some libraries to make it all work. And you can use things like Device Atlas or Wurfel to kind of make it work with server-side detection, kind of be able to differentiate or actually put devices into device classes to ensure this is a mobile, this is a tablet, this is a desktop, this is TV, whatever. But it's not that reliable. It's quite reliable, but it's not 100% reliable. But we can also use client-side feature detection, and you might be thinking about Modernizer, but you really don't need Modernizer for that. We can just check if query selector is in document, local storage is in window, and add event listener is in window as well. And if that's all true, well then we have a really wonderful, shiny modern browser. And if not, IE8 minus and its company. Right? So in many cases, these few lines of JavaScript can actually replace Modernizer altogether, which is quite cool. And again, I really, really find it cute that its modern browser is Chrome 1 Plus. This is so cool. It's like really, really nice. And Opera 9 and Firefox 3.5. This is so cool. Like from the very first version, we're going to be fancy. I like that. It's really cool. And here S40, whatever. Right. But this is just to make it clear. So they actually load more JavaScript when they discover that the browser is capable of it, just by using this little snippet of code. Yes, please take this picture. Thank you. Okay. But again, what do you do with fonts? Okay, I spend too much time, probably way too much time, analyzing what we can do with web fonts. I dream of fonts sometimes. This is how bad it is. And surprisingly, I spend most of the time in hotels at night, kind of trying to figure out what we can do with them. So there are many options, surprisingly, many options of things that you can do with web fonts. Well, so okay, let's say you want to deliver the content fast and you don't want web fonts to be blocking, right? So what can you do? Well, you can actually deliver a basic experience without web fonts to mobile browsers, and then just wrap your font face declaration within the media query. Okay, and then refer to this web font normally, but because it's defined in the media query, it's not going to be executed and download if you have a mobile browser or mobile device. So this is one thing you can do, but then you really have no web fonts at all on mobile. And why would you want to do that? Just to improve performance on mobile. Because web fonts are really killing. Like loading web fonts from FontDeck and Typekit and so on, it's really killing. Now the problem is you could just say, well, we're using FontDeck and Typekit and these fonts are going to be cached in HTTP cache. Well, they should be, but they are not. Because in our test we found out that for some reason, every 10-12 days, with different browsers behave differently, but every 10-12 days this font will be re-downloaded. Why? Well, the HTTP cache is not that reliable as we hope it would be. So this is a problem, and you don't want the fonts to be reloading and re-downloading all the time. It was quite annoying. So, we had to deal with it somehow. Okay, so what else can we do? Right, we can actually wait until the web fonts are loaded from from FontDeck and Typekit and whatever we're using. Show nothing until the font is loading, but you know how I feel about that. So we don't want that. What else can we do? Well, we can show the content in the fallback font first, then download web fonts asynchronously, and then we have a switch. But we would have it all the time. But every single visit the user comes to the page, we would have the switch. Annoying. We don't want that. Okay, so what else can we do? We can show the content in the fallback font first, download web fonts asynchronously, and then load web fonts save the web fonts in local storage or app cache, and then retrieve them on the next visit. So the users might see the switch, but they would see it only once, because then it would be actually stored in local storage or app cache. Okay, what else can we do? Can we do something with WebGL? No. Can we do something with WebSockets? Maybe. Well, we can do lots of crazy stuff. You can actually go ahead and store things as you like. Now the problem is, however, if you're using FontDeck and Typekit, you have a really limited number of options, because they are delivered from Typekit or FontDeck. So you have to include the script. But you can use this little snippet, JavaScript, which is called Web Font Loader. You might have heard of it. Web Font Loader, which allows you to load web fonts asynchronously. Then you also have a really better granular control, Web Font Loader, granular control about what you're loading and when. Right. Web Font Loader is a library that gives you more control over font loading than the Google Fonts API provides, and kind of lets you say, okay, if the font hasn't been downloaded yet, hasn't started rendering yet, I'm going to show the text in a different fallback font altogether. But what we also should do, and this tells me, that I'm spending way too much time on this. What we also can do is we can go ahead and for every single selector where we define typography, where we define web fonts, can go ahead and define a big verbose mobile OS font stack. Because we know that on Windows phones we would have Cambria and all the C fonts, and on Android we would have Roboto Sans and Droid Sans and Roboto Serif and Droid Serif, and on iOS we have lots of fonts as well, like Avenir, for example, Avenir Next and so on. So you can actually granularly change every single font declaration in CSS, and have these huge stacks which include both mobile OS stacks and web fonts and desktop fonts, if we wanted to. What else can we do? Right, we have WoW2, right? And some browsers support WoW2, which is a new standard for WoW. WoW is it's already a main standard for web fonts. Now, but with WoW2, it's not supported by everyone, so we would need to create a separate declaration for WoW2 and deliver it to browsers. Now, this is way too much time spending on web fonts, I guess. But this is what we went with, and this is what the Guardian guys did as well. I lost my clicker. All right. Okay, so you come to the page for the first time. If you have a stupid browser, you will never see a web font again in your life on this site. Okay? If you are a smart browser but don't support WoW, it's the same story. You will never see the web fonts. If you are a smart browser, you support WoW, but it's not stored in local storage yet, well, you don't see the web fonts. You see the web fonts only if you're smart, support WoW, and then the fonts are already stored in local storage in your device. Now that means, of course, if you come to the page for the first time, you see that content in the fallback font first, Then once the page has started rendering or has rendered already, you download web fonts asynchronously. They could be, encoded in base64 in JSON or base64 encoded in separate CSS file. You store them in local storage. This is what we do. You could do that in app cache or in the future with service workers cache API. And then you show the fonts. But if local storage is not available, you never see web fonts. So what does it mean? You come to the page for the first time, you see the full web fonts first, then the page starts rendering, you see the web fonts are being downloaded asynchronously, they're then stored in local storage, and you can choose, either you make a switch once, or you actually retrieve these fonts and display the content of the new font on the subsequent visit. Does that make sense? Do I spend way too much time on web fonts these days? No? Well, I should get a hobby or something. But, and this is not it, because you want to have some subsetting as well. For example, if you have different, the problem we ran into once, that you have this big font, and it's kind of shared across all the different websites by company, within the company. At the same time, it has all the glyphs, like Cyrillic glyphs, and Chinese glyphs, and Latin glyphs, and everything, and Greek glyphs. And it really makes the font big. So you want to be able to subset dynamically. It's really hard. But with WoW 2 you can do some stuff, because with WoW 2 the compression is much better. So you just need to basically, in order to do that, you can do the same thing. Then you create this base64 encoded in JSON or in CSS. But you do one version with WoW and one version with WoW 2. Then you decide with a little script again which version you load. But that's easy, because Friedman group has come up with this wonderful WoW 2 exactly. WoW 2 feature test. So it's really a small JavaScript. So you can just include it this way, like WoW 2 and WoW, right? And then you're using this JavaScript, that little script, to define, to decide, does the browser support WoW or not, WoW 2 or not. Now WoW 2 is really cool because it saves you 25 to 30% bandwidth. So it's definitely worth experimenting with. But this has one major problem. By the way, the reason why I'm talking so much about web fonts, because actually optimizing the delivery of web fonts was the major performance optimization we did, which actually saved us 600 to 800 milliseconds alone. Now this is really critical. There is one little problem here though. So if you're using web font loader because you're using typekit or font deck, you can't do this because it's illegal to just get the buffs and then base64 encode them in CSS or on JSON. You can do that. It's illegal, but you could do that. It's not that easy to get the fonts from Chrome cache actually, as you might think. You need some workarounds. I found a few. I can share with you with them publicly, without the camera later maybe, because it's really illegal. But what we did is we just talked to FontDeck, and we're basically paying the same amount of money every month, and then they just don't count the impressions. Font impressions. Because the reason why you include the script is because they want to, or callback, have a callback, but they want to count the number of font impressions you have on the page. But you can actually try to make it work, and if you have a web font, company-wide web font that you need to load everywhere anyway, and it's a company web font that exists on your servers, you can do it quite easily. Now, this is what they did, right? And the result was quite remarkable. So the result was the Guardian users need to successfully complete one HTTP request to start reading the news. One HTTP request. I repeat, Guardian users need to successfully complete one HTTP request to read the news. A median start render time for an uncached page is 0.8 seconds on iPhone 4 with a suboptimal 3G and 300 milliseconds round trip time. It's pretty good, I would say. Now, what does it look on desktop? On desktop is a bit different. With JavaScript, enhanced JavaScript loaded, front page has 35 images, 67 HTTP requests, and 657K. Median time for an uncached page to start displaying is 0.72 seconds. And this is a bit disappointing. I mean, it's pretty good, obviously, but if it's 0.8 seconds on suboptimal 3G, why the hell is it 0.7 seconds, 72 seconds on an optimal DSL line? This is just weird. It should be maybe 0.4 seconds or 0.5 5 seconds. But 0.7 is still quite, high, considering what they achieved on mobile. Any ideas?
You have much more requests.
Yes.
That's
But this is actually not. Why do you have so many more requests? I mean, if you have all the images, they have only 35 images, which makes 35 requests. That's quite a lot, but yes.
But you're never using the full bandwidth at the end.
Sorry?
You're never using the full bandwidth.
Yes, this is a good point.
Just going a bit and then again.
Yes, this is one point. The second main reason is actually, well, you couldn't have guessed, but the second main reason is that they couldn't push the advertising to the very bottom, to the leftover section completely. So they have to load some JavaScripts for loading the ads somewhere before the page starts rendering. So they couldn't actually make a political decision to move over there, which is why it takes so much time. But it's actually still pretty good, I would say. I would argue, right? And the page speed score is pretty impressive. So they had 88 on mobile and 69 on desktop, but actually it was, time when they actually were still experimenting with it. So they're kind of rolling out the new architecture right now. They actually started building it last year, early last year, and it took them almost a year to actually finish the entire thing. But they're rolling it out at betaguardian.com, I think. We'll look into it. It'll be quite interesting to see how far they've come. Oh, right. Do we have Wi-Fi?
Yeah. Have to find the password.
Okay. But if you want to look into them, but we just had it a second ago. Interesting. So it's beta.guardian.com. So you can just look into it, how far they've come so far. Right. So what does it all have to do with Smashing Magazine? Ah, by the way, they also open source the entire thing on GitHub, so you can go ahead and actually grab it. All right. Right. So who's responsible? Do you have a department for creative passwords?
I think it's keychain.
Oh, okay. It's keychain. Okay. 6H. Beautiful. Okay. Okay, I'll start my torrents. Ah, somebody got the job. That's nice. So you are using torrents after all. Okay. Ah, by the way, there is this. I was in the Netherlands the other day. It's so remarkable. They're not using torrents anymore. Oh, it's recorded, right? Interesting. So there is this new. They came up with an interesting system. It's really popular in the Netherlands, where they use peer-to-peer streaming, where they actually stream movies, but it's always on the network. So you always watch movies online. It's like YouTube, but you actually see full HD movies in 1080p, and it's just shared and stuff. I will maybe or maybe not tell you the tools that they're using later.
Shouldn't it be COUK?
Sorry?
Shouldn't it be Guardian COUK?
No, I think they actually need to come.
but the URL is wrong because it's the Guardian, not Guardian.com.
Sorry, the Guardian? Oh, right. I'm not sure if it's okay. Let's check. Oh, it's I hope it's better.
That's not the beta version.
It's not the beta. I think it looks a bit different. Maybe they rolled that out already. No, this is not the new version for sure.
Try next.
Next maybe.
No, beta is okay, but you have to write beta.theguardian.
Ah, here, this one. Right. Next. Okay. Well, it's not much better yet. Well, it's 91 on desktop, 78 on mobile. Okay, but they're still working on it, and they also open source the entire thing. Now, this is the only site I know, by the way, which performs better on mobile than on desktop, which is quite remarkable. Used to perform at least. Well, there is another one, which performs better on mobile than on desktop. But before we move there, I actually want to just explain you the situation we actually worried, why we actually had to improve so much. Now over time we actually had a lot of change on the site. When we started out it was just one code base and it was one site, but then we had different sections, and all the different sections wanted to have, well, had to have different installs because we wanted every single section to be kind of grow independently. Well, it kind of happened, but not for all sections. And in the end, it was really important for us to kind of bring it all together, because if you have different installs, so you know how it is with WordPress, you have, let's say you have an author, and he submitted articles in 3 or 4 different sections, but then kind of putting them all together in one section, like displaying them all on one page, is really hard, and really introduce lots of logics that you need to implement, stuff like that. That kind of increased complexity, and we wanted to bring it down to make it as simple as possible to one site. At the time when we did this separation of subsections, there was no multi-site, WordPress multi-site, so we actually did it manually. But this is what we had to deal with. At the same time, we had advertising loading first, which means advertising also required jQuery, which meant jQuery loaded first, and it also required some JavaScript, which meant this JavaScript were loading first. That meant before the content started displaying, we load jQuery and we load JavaScripts, and we just kind of load the ads and then we load the content. Now the ads would be loading asynchronously, but still kind of the main architecture, the main skeleton of the ads would be loaded first. And it really loaded the page. And at the same time we had web fonts delaying the loading of the page as well. Now that was not cool. Now we have a really cool user base, I must say, people like you, which is very fortunate for us, because we have 52% Chrome, 18% Firefox, 12.5% mobile, not that much, but it's growing, as you can see. 8.3% Safari, 5.3% IE, it's so nice, and especially this one, it's really cool. And we have, I tell this joke all the time because it's so funny, we have one person every single year, must be doing it on Christmas or something. He comes to the page with the user agent string Internet Explorer 666. That's very and it kind of shows up in the statistics, which is nice. With one person, 0.00000%. But it's kind of cute. And then we have Opera with 1.2%. Well, but you know, if you have 10 more visitors of Opera visitors a day, it already increases everything by 1000%. So this is, you know, not a big deal. But still interesting to keep in mind. Now, we had a few problems again. Independent sections with separated WordPress installs. Accessing content was difficult on slow connections. Wanted to decouple JavaScript dependencies. And wanted to deal with annoying web fonts loading. With ultimate goal actually is the same like what the Guardian guys did. One code base, one responsive site. But more specifically, we never actually thought about how fast the page, you know, should be, but actually more about how fast we can make it in general. So it was never a point, let's make it, you know, run fast, around, I don't know, 1.3 seconds or so on a specific connection, but more about how fast can we be in theory. Like, we wanted to push really, really hard. And it was cute, because we had to kind of identify what, you know, fast means. Now, how fast is fast enough? Paul Irish has this, one of the comments in Tim Kedlick's articles, he wrote that according to Google's recent studies, a speed index of under 1000 is of big importance. How many of you are familiar with the speed index? Okay, so yeah, I'll probably show it now. So if you're using tools like web page test in order to check performance, web page test is fantastic because you can actually go ahead, check any page you like, Smash Magazine, any location you like, let's say Amsterdam, browser you like, let's say Chrome, and the connection speed, cable, 56K dial-up if you want, cable DSL and so on. And you can also choose the number of tests to run. And what it's going to do is it's going to take one of the servers in a specific location, it's here in this case Amsterdam, and it's going to run this test with an uncached page and a cached page, and it's going to display the results. How fast the page starts rendering, how fast the page is loading and so on. But what's really important, at least this is what we found out, you can't just use one test. That doesn't give you any results. We tend to use run 5 times, maybe 9 times, because 9 is the maximum. here, just to get something like meaningful results. Because latency is going to vary so much, you have to be, you have to work with average results. So, and the reason why I'm showing this to you, because once you run this test, it's going to show you some metrics about how fast the page is loading, how much time it takes to start rendering and stuff like that. But actually, we often tend to focus a lot on start loading time, loading time, or full loading time, but it's really not important at all. I mean, nobody cares. What's much more important when the page starts rendering. So I want to minimize the start render time as much as possible. I want to make it kind of display, the content to display, and the functionality to be displayed and be available as fast as possible. I'm just trying to talk as much as I can before we see the results, right? And it's damn slow right now. And I don't know what to say anymore. Yes, it's complete. Now as you can see, we have some really bad stuff here going on. I have no idea what's going on here. That's very strange. Wow. Oh, this is, I don't know, I have to look into this.
For the first byte time?
No, well, the first byte time is really, wow. But start render time is 0.3 seconds later. So that's nice. I don't know what's going on, we have to rerun it. That's very strange. But the idea here is you can also see the speed index. And speed index should be around 1000, or actually under 1000. So, let me rerun it. And the speed index means basically if you, well, it doesn't kind of, it's not like a mapping one-to-one, but actually it's very similar. If you say that speed index is under 1000, it kind of means that the page starts render under 1 second. This is what you want to achieve. Now with Google results, with Google findings, they found out that if you want the page to kind of be fast and feel fast, and it's not just Google who found it out, you want to stay relevant and display content within 1 second. Once you kind of around 2.5 seconds, it starts feeling slow. And once you're beyond 2.5 seconds, you're lost. Users are gone. So they're not going to come back maybe. Or maybe they do, but this is kind of the problem. So you have 1 second to actually make it work. Which is not a lot of time, considering that so much time goes lost on mobile connections. Wow, I have no idea what's wrong with this server. This can't be true. This is very strange.
So much traffic on your site.
I don't think so. I should go to a different one maybe. Let's go to this one. It's very strange. Right, but we will get back to it in a second. Now the speed index again is a value that is calculated. So it's not like you can tweak the value very granularly. This is just calculated based on latency, based on the speed you have and so on. But if you want to get there in this area of 1000, you have to deliver the critical path view, or the so-called above the fold view, in the first 14 kilobyte of the page. Now are you familiar with this value, 14 kilobyte? Who is familiar with it? Right? So the reason why it's 14 kilobyte is not because it's a magic number that just works everywhere. It's because again Google did some research on the properties of TCP/IP protocol and how packages are exchanged. And they found out that if you want to deliver the critical content within really as fast as possible and ensure that you don't have too many round trips, you have to ensure that your critical CSS and HTML are in the first 14 kilobyte. Now what is critical? Can somebody explain what critical CSS is? Core content. Yeah, so we talked about core content, but of course, well, you can't load everything within the first 14 kilobytes. This is just not how it works. Usually CSS alone is 50 kilobyte, maybe 70 kilobyte, depends on the page. But you can go ahead and look specifically for a given page. You can look at the first 800 to 1000 pixels. You can look at this area, this visible area, across all breakpoints that you have, and collect all the CSS that is required to actually load the content in this viewport, in this 800 or 1000 pixels height, but across all the breakpoints. And once you do that, you can actually push it very hard in the header of the page and add it inline with inline CSS in the header and deliver it as fast as you can. Because then this portion is going to be visible very fast and the rest is going to be loaded later. Does it make sense? So like you can't push everything into 14 kilobyte. You can identify the critical CSS that you need to display the first 8 to 1000 pixels height on your page. And really push it very hard in the header of the page, inline it, and then the rest, the rest of this HTML and the CSS will be loaded later, and JavaScript too. And this is what you have to deal with. This is why we had to do a lot of stuff to actually find the selector, because no tools existed back in the day when we did that. Actually, just 5 months ago. But there are many tools existing today that can enable you to do that very quickly. So yeah, you want to be within one second, which is a really tough budget to get. And I don't know if you're using a private instance of web page test. So this tool, you can actually go ahead and install it on your local server, and then run it all the time. You have to wait until the test is complete, right? But you can make it work. And you can also use grunt tasks if you want to define a performance budget. Let's say you want to be the page to start render under 1 second. Well, you can actually define a performance budget in grunt. Now this is a grunt task, a budget task, which allows you to do just that, where you just identify your key, API key for web page test, and then you go ahead and you can define your budget. For example, visual complete under 4 seconds, and speed index under 1500. And then as you build or deploy, kind of prompts an error message saying that if you are beyond the budget, and tells you are beyond the budget, you have to fix something. You can actually connect it with GitHub as well. So if you are, you have a commit, it won't merge unless you fit that budget. So it will actually throw an error saying you can't commit that, you can't merge, because you're not meeting the budget. So you can be really brutal with it if you want to. And I'm really curious about that page speed thing. This is still not good. I'm not sure why. Debugging live?
Maybe you should go to Frankfurt or somewhere.
Sorry?
Maybe you should go to another location.
Maybe let's go to Copenhagen. Actually, I just want to run, let's say, 5 tests. It should be fine, I'm not sure why. Let's see. Okay. This is not cool. I'm not sure why. So this is the 6 HTTP request we're talking about. So we have HTML, CSS, and CSS is inlined. Then we have a logo and background image and a few images. And of course, until they're loaded. But this is done here. Why is it waiting until 102? That's very strange. I have no idea. Well, I would need to look into this. Might be something with the server, I don't know. Right, so, and again, at this point, well, we did exactly the same thing. We consider 3 types of page content: core, enhancement, and leftovers. And core is the same story. Enhancement is the stuff we use in order to, enhance articles. We have a syntax highlighter, full CSS, web fonts, comments, also gravitas, right? And JavaScript. We don't need that much JavaScript, but this is what we're loading as enhancement. And then leftovers, right, gravita images are leftovers, not enhancement. Advertising and analytics. Now moving leftovers over here was really hard. So I kind of made a promise to, okay, let's test it for a week. And if we see that ad impressions haven't changed, like the click rates haven't changed, we just keep it this way. If they have changed, we'll reevaluate the entire thing. But we moved it over there, and we're loading them last. Nothing changed. So we keep them there as well. And we do exactly the same thing that the Guardian guys do, right? This separation of concerns. And if you want to sum up everything we did in one little slide, this is it. This is all we did and nothing more than that. Optimized for delivery of the content and defer the rest. This is the main thing. And basically what you do is, you can make your responsive site fast if you just prioritize enough. If you have really clear priorities, this is all you need to do. This is all you need to do in order to make it fast. So what we do is we load critical CSS inline and full CSS on load, which means we had to manually identify all the selectors that went into displaying the first 800 to 1000 pixels across all breakpoints, and we collected them all and we pushed them hard inline CSS in the header. I will show you an example in a second. We try to avoid JavaScript libraries, not because I hate JavaScript, just because I'm not particularly a big fan of it. So if we can avoid JavaScript with CSS, we do that. If we can avoid jQuery with JavaScript, we do that. If we can avoid jQuery or any JavaScript with smaller libraries, we do that as well. Like best practices, nothing particular. But we had just a few things that relied on jQuery, so mostly advertising. We rewrote it in JavaScript because we have a really cool user base and we don't have to worry too much about A8. Also, when it comes to A8, we actually removed Respond.js, which we used to use a while back. And we just send it to a fixed width layout, and I hate you A8 CSS file. That's all. And then we store web fonts in local storage, and we set cookies. So the user comes to the page for the first time. They see the content in the full web font first. We're downloading the web fonts asynchronously because they're stored in web font CSS. We're going to differentiate between WOF2 and WOF in the future. And then the fonts are loaded in local storage, and then we have a check before the content is displayed. If the cookie has been set, then we're kind of retrieving the font from local storage. It takes maybe 40 to 50 milliseconds. And then we're displaying the content in the web font right away. We defer advertising, tracking all non-critical CSS in JavaScript, and we kind of try to optimize the critical rendering path for content delivery, just to ensure that nothing that is blocking that can block is blocking. Right, but this is so the critical rendering path, as Ilya Grigori kind of defined it, is a chain of events that need to take place in order for a browser to start rendering a page. So by default, everything is blocking. Network latency is blocking. Because of network latency, we can't see anything. We need HTML, we need CSS, we need JavaScript. Sometimes, often not, but we need actually just these three in order to display the page. Right? And everything else is deferred. This is not a big deal. But what I wanted to show is how we actually can go ahead and grab all the critical CSS. So we have to kind of identify critical CSS and gather it, right? And then load critical CSS inline, and then load the rest asynchronously, and then maybe set a cookie to check if the reference have been loaded, if the CSS has been downloaded already. And if not, then we are loading inline CSS. If it is, we're just inserting it using link ref. And we can actually also automate it with task panels like Grunt. And again, critical CSS is a subset of CSS needed to render the top portion of a page across all breakpoints. This is what it would look like with something like Enhanced.js, which is what Friedman group is using, where you have you're checking if the cookie for full CSS has been set. If it is set, just include it as link rel style sheet, because it's going to be in the HTTP cache already. And if not, well, you're kind of putting critical CSS inline in the style tag, and then you also have the no-script tag for browsers that don't support JavaScript. So they also get some fancy CSS. And you can use critical CSS or Grunt critical CSS to have something like this, where you can define this visible portion. For example, you want to cover 1,200 pixels width and 900 pixels height, and you want to collect all the CSS that is kind of influencing the display of the page in this range, just in this box. And you can do this. You can just send this critical CSS Grunt task to go through all the URLs, all the CSS files that you have, and it's going to use Phantom.js to actually run the page in the web headless browser, and then see what CSS selectors are being used. And then it will actually store all these selectors in this file. That's pretty cool shit. Right? Yes, this is pretty fancy. It's not 100% reliable, sometimes you'll need to do some cleanup, but it's also pretty cool. Right. Now, did it help us? Well, it did help us. This is the result we ended up with, where you have 98 on mobile and 99 on desktop. We're kind of behind that now because of another ad we have to add right now, this test. I hope it fails. But we have 98 mobile, 99 on desktop. And if you go on the web page test, for example, we have Amsterdam NL, I think it was 3G, this is fine. Amsterdam NL, Chrome cable, you end up with a start render time on exactly 1 second, something like that. Or the subsequent views, it's under 1 second, but mostly because we lose so much time in this due to this damn servers in Freiburg, which we're moving away from right now. So the first byte time is 0.58, 0.6 seconds, which is terrible, like really, really terrible. So we have to move away from this. We are on it already. But despite this, only 0.4 seconds is a delay between the first byte and the start render time, which is, I think, pretty nice. And we don't have a lot of traffic, I must admit, like 47 HTTP requests and 425 kilobytes of data on the front page. And on subsequent pages, because we cache so much, and including web fonts as well, we have just 8 HTTP requests and 49 kilobytes. And it takes exactly the same time. This is so disappointing. Because of the local storage, we have to retrieve the fonts and stuff like that. This is so disappointing. For 8 HTTP requests. But okay. And if we are lucky, this is kind of the results we ended up with. We end up with first byte time 0.8 seconds start render time. And again, we're kind of circling around 1000, but sometimes we're hitting it, sometimes we don't. Right, because we run this test with fast click. I'll mention it as well. And here the start render time for the subsequent visits is 0.68 seconds, which is, I think, quite nice. And that for 0.4 seconds first byte time. That's amazing. Now what we're trying right now, and this is what I want to show as well, because it's really quite nice. I'm not sure why it's like that. Oh. I mean, there is nothing here. What is this? Maybe something with the server. Have you heard of InstaClick? Instant click. Now this is a bit strange. Not that you haven't heard of it, the tool is strange. So the idea here is, well, if you're using a mobile device, and you want to, for example, click on a link, right? Well, then you are kind of focusing around this link, and then you click that link. But there is a latency, or there is a delay between the click and between focusing on the link. And this tool tries to minimize this delay. So the moment you kind of mouse over the link, it starts preloading the link for you, or the contents of the link for you, like all the assets it has. So we're testing it right now. It's 4 kilobyte extra kilobyte of JavaScript, which we add now and test for these 2 days, just to see if it actually brings any performance improvements for mobile. It's cute. At the same time, what you can also define with tools like jQuery aim, I think, can say, okay, this is my dot, right? Or this is my link, for example. If the user is within 200 pixels of that link, I'm going to preload the content of that link. Well, maybe, sure. But in our case, if we know that the user is actually hovering over the link, we are starting preloading the link for him. So that when he or she clicks on that link, the page is going to be available right away. So this is like probably something you can see here, but actually you can best see it on mobile. I don't know, let's go to whatever. So here, once I hover over it, I should be able to see in the network here, should be able to see things loading, preloading. Yes. Is it? Or maybe it's in our test environment still. Maybe it's still not implemented. Strange. Should be. Need to go into Trello now. Damn it. It's done. Okay, ich weiß nicht, ob es schon, I don't know if it's already live or not, but it should be. So if you go on Test Action Magazine and, oh yes, it's better on phone. So if you're kind of tapping on something, then you are going to, the image is going to be downloaded. Just a second, I have to reply to a message from my girlfriend. She's looking for me. I'm sorry. Oh, it's recorded. It's very nice. Okay, so I'll better wrap up soon, I guess. Right. But the point is, again, we're just testing some stuff now. So the start render time is still pretty good. And again, it didn't take us too much time to actually make it work. So kind of figuring out what to do and how to do it took a bit of time, but actually implementing these few things that we did, like rewriting a bit of JavaScript and stuff like that, took us two and a half weeks to make it work. And now I can finally, read our articles on Edge and edit our articles on Edge. And this is just remarkable because also a few weeks ago I received an email from one of our readers. Alright, I'm not there yet, but it's okay. One of our readers said that Smashing is the only site I can read on an Edge connection when commuting in Sao Paulo every day. It makes me think why other sites aren't optimizing for slow connections too. Which kind of is the point of what we did. And I'm really happy that somebody actually who couldn't read our articles can do it now. Now we still have a lot to do. Like this is just, we just did some basic stuff. We're going to use source set and the picture element for images and articles. Right now we're just delivering one single image to everyone, which is, we can do so much more with this. We are already using ground performance budget to track performance. We are going to measure changes in traffic, but ad impressions haven't changed. But we don't know about traffic because it so varies depending on the articles that we publish. So we don't have any meaningful results just yet. Reviewing articles for performance before publishing. Now this performance thing and this kind of focus on performance introduced lots of changes that are required now for the editorial. So every single time somebody goes on the page, somebody wants to publish an article, they have to make sure that we hit this page score for that specific article. So all images have to be optimized. And we have to make sure that we don't load too much stuff. And it kind of introduces another barrier for people to use, but it's fine, I guess. It's fun sometimes, and sometimes it's not. And still we have a few things, like we discovered a few web views issues. So if somebody opens a link on Twitter or on Facebook app, then the article is loaded and the web fonts are downloaded asynchronously. But the problem is that they're not stored. Because web views don't, some web views do, but most web views don't have persistent local storage or cache, which is kind of weird because they should be, but we're looking into it right now. Now obviously, if you have, we're loading a big chunk of CSS at the top of the page, right, and then the rest loading asynchronously later, but it means that the styling for comments, because it's not in the visible portion of the page, is not loaded first. So if you're sharing a link which leads directly to the comment section, you will see a few jumps just because CSS is being downloaded. But we kind of made it work. We included some of the critical CSS for styling the comments in the header still. And then we're deferring routers, we're doing it right now, move to new servers and so on. Also Speedy is kind of something that we actually wanted to introduce. Have you heard of Speedy? Speedy is this new protocol that Google is being developed. But there is one major problem. Have you been actually using it a lot, or have you heard of it? Who has been using it in production? Okay. Now we wanted to use it and we couldn't, and the reason why is because some advertisers want to deliver images from their servers, but Speedy actually requires you to use HTTPS. So everything on Speedy goes through HTTPS. If you're using any non-HTTPS images, or assets, it just throws an error, just because it has to be HTTPS. Kill me now, really. These advertisers are really killing me. I mean, every single time I stumble upon something, we can't do that. Because Speedy promises lots of really good results, but we're not there yet again. We have to deal with, advertising somehow. Right, so the Friedman group has written an article about what they did to make responsive sites fast, and actually many things that they did are very similar to what we did. And I also published this article where everything is listed, all the snippets we used, and all code snippets, and all the techniques we used, and so on, with all the links. You can just go ahead and use it right away. Or if you want to get a recap of everything we did with all the tests and all the results, you can actually get that too. Right. So with this in mind, I'd like to thank you for your attention. I mean, the improvements itself was kind of a really strange way, just trying to figure out the best way, what to do and what to load, and also do some compromises with advertisers and so on. But actually making it work was not that difficult, really not that difficult. I mean, I don't know what's happening right now with the servers, but actually staying under 1 second, 1.2 seconds is really not that hard. It really isn't. So if somebody is telling you that making responsive websites fast is very hard, or well, it's not easy, but the making responsive sites is almost impossible, they're liars. Because you can do it if you just have priorities set straight. If you have clear priorities, you can reflect these priorities in the way that the ads are loaded, that the assets are loaded on your site. That's pretty much it. Because once you have that, you have really good beer afterwards and be happy about it. Okay, thanks for your attention. Cool, I also have some stickers and stuff. You can just go ahead and grab them if you like.
Oh, only the